Hey everybody, here's the notes for 7.3. First, in this first problem, we're not going to do anything different from what we did in 7.2. Nothing different at all. We're going to just look at some key features of a transformed exponential function, which we did in 7.2. We're going to transform one particular ordered pair and see how that goes. So let's just get after it. And after 7.3, we'll talk, after this first example, we'll talk about what's going to be new in 7.3. So here's the function. F of x equals negative 2 to the x minus 3, right? The parent function is this right here, just the base value b raised to the x power. And it contains the point 3 comma 8. So there's the parent function. And we'll put the ordered pair 3 comma 8 down there. We'll deal with that later. And we'll transform that to its new location. But here's a graph of this function. Just put this in as a graphing calculator tool. This is what will come out. Let's answer these familiar questions. We'll get familiar answers. What is the domain? It's always all real numbers for exponential functions, no matter how they've been transformed. From negative infinity to positive infinity is the domain. The range, clearly going all the way down to negative infinity, would be the lowest y value. What's the highest y value? Well, they seem to be climbing up towards 0, but not quite reaching 0. And the fact that there is no vertical shift out here at all confirms for us that, yes, those y values will approach 0, but not ever actually include 0. Right? And so that tells us that there really is no x-intercept also. It tells us that there is a horizontal asymptote at y equals 0, and that one of the end behaviors, in particular, as x approaches negative infinity, which is going in that direction, that the y values are approaching 0, right? There's always a connection between one of the values in the range and where the horizontal asymptote is and one of the end behaviors. There's always that connection in these exponential functions, right? Well, we skipped over a couple of these questions. Y-intercept, there is a y-intercept on this graph. We can see that it is ever so slightly below the origin. So it's going to be 0 comma negative something really small. How do we find it precisely? The same way we always find a y-intercept. Plug 0 in for x. So if we plug 0 in for x, we get f of 0 equals negative 2 to the 0 minus 3. You can put that in your calculator, calculate the result. It's going to come out to be negative 0.125 or negative 1/8. And if you're skilled with your graphing calculator tool, you can get the graphing calculator to give you that precise intercept also, but we don't need the graphing calculator. We don't need a picture of the graph at all to be able to calculate this. All right, for decreasing and increasing intervals for exponential functions, it's always all one or all the other, right? Exponential functions are either always increasing or always decreasing. What are the y values doing in this particular graph? Well, they're always decreasing. Even around here, it doesn't look like they're decreasing here. It looks like it's just completely flat, but trust me, they are decreasing as you move to the right here. And you could see that if you zoomed way in on that graph. You could see that the values are going ever so slightly down. Okay, but if you just recall, look, the function values are always decreasing or always increasing. It's very obvious that the function values are decreasing out here. And so they're decreasing everywhere. So from negative infinity to positive infinity is where they're decreasing, and there is no increasing interval. The only question we haven't answered so far is this one, as x approaches positive infinity. So as the x values get larger and larger and larger, the y values are getting more and more negative. And that's that, okay? This is nothing different from what we did in the last lesson, 7.2. Absolutely nothing different at all, right? And this is not going to be different either, transforming this ordered pair, right? We have to note what the transformations are, okay? There is this transformation here. There is a -3 alongside the x, and there is a negative out in front of the 2. Now, that's not a shift, okay? We didn't see this particular transformation in 7.2, but we have seen this transformation in the past. This is a -1 times the 2, right? This function could be rewritten like this. F of x is equal to -1 times 2 to the x minus 3. Okay, that's a multiplication, and it's a multiplication out in front of the parent function, which means it's a stretch or a shrink depending on the value of that multiplier. If that multiplying value is larger than 1, it's going to stretch things out. And if it's less than 1, some value between 0 and 1, it's going to shrink them down. But also, because this is just a 1, so it's not going to stretch or shrink, because of the negative, that creates a reflection. Okay? And it's reflecting the y values. It's turning positive y values into negative y values and vice versa. So y values are going from up to down and down to up. And so we describe that as being a reflection across the x-axis. Okay? It's y values that are changing. Okay? We might say it's a reflection in the y direction, but it's a reflection across the x-axis is usually how we describe it, okay? The order of these two particular transformations really doesn't matter. We could do them in either order and we'd end up okay, because one of these transformations is applied to the x values, the other transformation is applied to the y values, and so it really doesn't matter which order we do them in. The order matters when you have more than one transformation being applied to, let's say, the x values, or more than one transformation being applied to the y values. Then it matters what order you do the transformations in. Okay. Well, this -3 alongside the x, minus makes us think in the negative x direction, but we know the actual shift is always in the opposite direction from the way the sign would suggest. And so we're actually going to be adding 3 to all of our input values. So adding 3 to the 3 gives us 6. And then this -1 times is being applied to the function values, the y values. So we're going to multiply all the y values in the table by -1. And so the +8 turns into a -8. So the point 3, 8 gets transformed to the location 6, -8. And if we did those transformations properly, we should be able to judge that the point 6, -8 really is on this transformed graph. And if we look at the graph, here's 5, 6, -1, 2, 3, 4, 5, 6, 7. Yeah, it looks like 6, -8 is on the graph. So that's good. I mean, if we had come up with a point that was definitely not on the graph, then that would be a big clue that we had done something wrong in our work in the table here. Okay. So all of this is familiar from 7.2. The only thing we didn't see in 7.2 was this particular type of transformation. But we've seen that type of transformation in the past with quadratics and with polynomial functions, and just with functions in general. Okay. So what's new in 7.3? Well, nothing really. The fact that these exponential graphs are being reflected now. That's the only thing that's different in 7.3. Did it confuse us? No. Did we have to learn something new to know how to deal with that? No. I mean, there's kind of nothing new in this lesson. Okay. I mean, we are seeing the graph of an exponential function that is different from the way all the other exponential function graphs have appeared in the last two lessons, because in the last two lessons, all the exponential functions were above the x-axis like that and going up, or like that, but they were, for the most part, above the x-axis, unless we shifted them down a little bit, right? All of our functions look like one of these two. But because we have reflected with this -1 of function, we've taken essentially this function here, right, and reflected it across the y-axis, across the x-axis. So now it looks like that. And we didn't see any exponential functions that were completely underneath the x-axis before. But that doesn't change at all, not at all, how we think about or answer all of these questions about key features, or how we process the transformation of an ordered pair. Really, it doesn't change a thing. Okay? I'm going to work through one more example in case you want to see one more example. But there's really nothing new in here, but maybe you'll want to stick around for, again, this reflection idea when we're transforming the point, okay? All right, so here's a picture of the graph of this function whose parent function is just 1/3 to the x power, which has the point -2, 9 in it. What's the domain? It's all real numbers, as always. Okay. The range, there appears to be a horizontal asymptote here at -4, and that confirms that these y values never get below -4. That's the lowest y value. In fact, -4 is not even really included, right? And the y values seem to go up to positive infinity over here. X-intercept, there definitely is an x-intercept here, but that is definitely not a question that I will be asking you on the quiz. Graphing calculator tool, if you're skilled with it, can help you find it, but we're going to teach you soon how to find that x value precisely algebraically. And so we're just going to save that question for later. The y-intercept, there does seem to be a y-intercept at around -1 to -3.5 approximately. How do we find it exactly? Same way we always do, plug 0 in for x. So 1/2 times 1/3 to the -0 minus 4. Well, -0 is still 0. 1/3 to the 0 is 1. 1 times the 1/2 is 1/2. And 1/2 minus 4 is exactly -3.5. You could plug all that into your graphing calculator and let it tell you that the result is -3.5. Decreasing or increasing, this function is always clearly increasing. The y values are going up all the time. There is no decreasing interval. Horizontal asymptote at y equals -4. One of the end behaviors is also going to be -4. It's this one here. As x goes towards -infinity, the y values get closer and closer to -4. So once again, there's this -4 showing up in all three of these answers. Okay. As x goes to positive infinity, the y values get infinitely large. And that answers all of those questions. Now let's do the transformation of the point. We have three transformations here. We have this -1 times x. Again, think of that not as a subtraction, but as a -1 times the x. And then we have this, which is a vertical shift, and then this, which is a vertical shrink. So we have two transformations in the vertical direction. It matters which order we do those transformations in, right? And again, for order of transformations, think order of operations, okay? The first operation would be this negative applied to the x. Okay, so we're going to multiply the input values, the x values, times a -1. That turns that -2 into a +2. And now, between the 1/2 times and the -4, which one of those operations happens first? The multiplication out here or the subtraction out here? It's the multiplication, right? So we're going to multiply this y value times 1/2. 9 times 1/2 is 4.5. And then we're going to subtract the 4. 4.5 minus 4 is 0.5. So our original point, -2, 9, ends up at the location 2, 0.5. And if we look at the graph, it should look like there is a point at 2, 0.5. Just cleaning up the graph there. 2, 0.5. Yeah, that's what it looks like to me. I mean, you see this gray point right there? That doesn't look like it is quite at x equals 2. It looks like it is ever so slightly less than x equals 2. That looks like it's at about 1.9, 0. Okay. I mean, you can see that gray dot is not quite at exactly 2. So 2, 0.5 right there. That looks right to me. So there's that transformation. Okay. There are 3 homework assignments for tonight. And the questions aren't any different. Not any different at all from what you saw in 7.2. Okay. I do recommend them as practice and preparation for the quiz coming this Thursday. And if you want any additional practice and preparation for Thursday's quiz, go back and do the 7.2 homework assignments over again, right? Because those questions are as good as any other new ones I could give you. And you've got nothing to lose by redoing those homework assignments, right? If you get a lower score than you got the first time around, Canvas is still going to keep the higher score, right? So that's what you got to prepare for Thursday. On Thursday, as usual, well, Friday, I guess probably. If you're watching this video, it's probably because you're in my class on Friday. We'll spend the first few minutes of class just checking in, maybe reviewing 1 or 2 sort of key things that it's easy to make careless mistakes on. And then I'll just say, if you're ready, go take the quiz. And if not, you'll have till like midnight Friday or noon the next day or something like that to take the quiz. All right. Reach out to me if you got any questions about anything. We'll see you